vehicles. That's why the environmental impact is happen as per the global has been heated by the using of the global warming. So we can switch with the electrical vehicles. The IC engines can be has a more losses. Approximately the 60 to 70% losses are in a IC engine. They can give only the 30 to 40% of the efficiency of IC engine. Most of the losses in IC engine in a engine losses, auxiliary electrical losses, idle losses, and drain power losses. In electrical vehicles, the losses should be minimum by the using of the different controlling techniques. Now you see, the electrical vehicles has a auxiliary losses, battery charging losses, power drain system losses, auxiliary electrical losses, and idle losses must be zero. Approximately, the electrical vehicle losses are goes to the near to the 10 to 20%. By the using of the regenerative braking, we can achieve the maximum losses. By the using of the regenerative braking, we supplies to the near about 70% of the back to the energy to the batteries. Nowadays, the electrical sector is rapidly growing sector. It is environmental friendly and eco-friendly also. The EV sector is share shares is rapidly increases, and many countries is contribute to the growing of the EV sales. Some countries are give some incentives in a EV vehicles to grasp the industry of electrical vehicles. Some battery advancement like a BMS controlling, BTMS controlling, these controlling techniques and some motor controlling techniques are in present nowadays in electrical vehicles. That's why the efficiency of the electrical vehicles is gradually increases. We use the battery for the storaging part and motor for the drive the vehicles. The electrical motor is used a crucial role in an electrical vehicle. To drive the vehicle, we can use the electric motor. Approximately the 90% of the electrical power in an electrical vehicle is goes to the motor to drive the vehicles. That's why the electrical motor choosing their efficiency, their power is must be significantly studiable. The today's webinar is also is informative and useful for the your futures. So now we're discussing about the some basic parameters of the electrical vehicles. You can see in a picture the electric traction motors are used to drive the vehicles. By the using of the motors, we can drive the vehicles. Next is a power electronics controlling elements are used. This is the basically use the controlling the power of a motor. We achieve the different speed at a different load condition. In a gradient, in a inclination, we can use the different speed and different torque. That's why we can use power electronics controlling equipments. We are also use DC-DC converter. The DC-DC converter is nothing but the buck boost converter. According to the electrical vehicles accessories is operate, we can apply the voltage of the accessories. The most of the accessories are run in a 12 volt supply. The battery can use most of the 48 or 60 volt supply, and auxiliaries are applied to the run to the 12 volt supply. So we can decrease the supply voltage 48 voltage to the 12 volts. So we can use the DC-DC converter. The DC-DC converter is nothing but the buck converter. The auxiliary equipments are the headlight, wiper, indicators, lamps, also some another applications in inside the vehicles. These operate by the using of the controller also or some switching method also. Now, the thermal management system are used, thermal system. These are used to provide cooling system of a battery. The battery can gradually charges or some drag some more torque or more power through the battery can be heated. So, to maintain the temperature of the battery, we can use the thermal management system. The thermal management system is used as a liquid form or natural air cooling form by the using of the various liquids and also the natural cooling by the using of the fan. The auxiliary battery are used. The auxiliary battery used for the running the auxiliary equipment of the vehicle. We also use the on-board charging system and off-board charging system. The charging levels are different in as per the requirement of the vehicle. We can use the level 1 charger, level 2 and level 3 as per the our requirement. Most probably the level 2 charger system are used, and fast charging we can use the level 3 charger. The transmission system are used. Motor must be run as a high speed because we can collect the maximum efficiency of the motor. That's why the motor can be run high speed. But at the initial condition, we cannot afford to the high speed of a motor. That's why we can use the some transmissions. The transmission likes we can use the gears, belt drive system. We can discuss about the further gear system to reduce the speed of the vehicle and achieve the maximum torque of the vehicle. The traction battery are used. The battery purposefully are used to the store of the charge. The battery can store the as a chemical energy and it is given to the motor to drive the vehicles. In a nowadays, the electrical battery are used lithium ion cells. It is the most efficient and high power density batteries. The most of in electrical vehicles, the maximum cost of vehicles are the batteries. Approximately 70 to 60% are the cost of the battery also. But the power can given to the vehicle is use a motor. That's why the motor is crucial part in a electrical vehicle. Nowadays, we can use the different vehicles. You can see we can use the conventional DC motors, brushless DC motors. Both these motor, conventional DC motor and brushless DC motor means BLDC motor, both are used in a DC power supply. Next, induction motor, permanent magnet synchronous motor, synchronous reluctance motor and switch reluctance motor. These are motor are run using of the AC supply. Battery can store only a DC. So we need to convert DC to AC by the using of the inverter. In this induction motor and permanent magnet synchronous motor, switch reluctance motor and synchronous reluctance motor, we can use the inverter circuit. That's why these motor are the some costly by the using of the inverter. So next is the first we discussing about the conventional DC motor. This is a normal DC motor. We can use the more in applications. So nowadays this motor cannot be used. Why? Because the losses of this motor is very high. Why? This motor is used the brushes. Now see in a picture, the DC motor is basic component are the stator and rotor. The stator is the stationary part of the motor and rotor is the rotating part of the motor. The rotor is given to the supply by the using of the brushes and commutator. The brushes are made a carbon material. Why? Because the brushes is given to the rotating part supply. That's why there are need less friction. But these friction are produces the more heat. Also they are produces the arc. It is directly impact to the efficiency of the DC motor. That's why we have some modifications in a DC motor. The bearings are used for the smooth running of a rotor to reduce the friction losses of the motor. Field winding is placed in a stator of the rotor. It is used to produce the flux, and armature is also used to producing the flux. The commutator are used to give into the supply to the armature winding. The stator and rotor are most probably use the iron material. It is made in a iron material. The both winding are the copper winding to reduce the minimum resistance of a winding. The working principle is very simple. The working principle depends upon the Faraday's law of. It is said that the current carrying conductor, the placed in magnetic field, it produces the force and they can be rotated. Means you can see in a picture the two part are used, the stator and rotor. This is the middle one is a rotor, and outside N pole and S pole it is a stator, means it is a stationary part. The rotor is both side of the supply, stator and rotor also. The stator can produce their own flux and a rotor also can produce their own flux. These two fluxes are interact to each other. They experience as a force, and rotor means armature that can be rotated. The rotor supply is given to the by the using of brush. They produce the more losses. That's why we some modifications in a rotor side to improve the efficiency of this motor. These modifications is turned into the brushless DC motor. It is said that simply brushless. What is meant by brushless? Means there is no using of the any brushes, and it is operate a DC supply. That's why we call it as a brushless DC motor, BLDC motor. Basically, two types of motor are used. First one is a fixed motor, and the second one is the hub motor. The first one is a fixed motor, means the outer side means stator is fixed and inner rotating part is a middle part is a rotating. But in hub motor, the outer side is rotating and middle part is a stationary. You can see this is a motor used in electrical different vehicles like TVS, Hero, Bajaj also. We can see in a further. The working principle is similar to the DC motor, but they has some magnetic locking. That's why we can use some switching frequencies. You can see in a picture. The outer side is the stator. It is used 3 poles, and middle part is the rotor. The rotor is used permanent magnet. Why? Because we can produce the constant flux. The constant flux is given to the by the using of the winding or permanent magnet. The winding can given to the supply by the using of the brushes. The brushes can produce more heat, more loss. That's why we can introduce the permanent magnet. The permanent magnet is placed inside the motor. It is called as the rotor to achieve the maximum efficiency of the motor. The supply in our commercial is the AC, and motor can run with the DC. We can use the AC to DC converter. It is a brushless. That's why efficiency is high. See in a picture, the working principle is the 3 poles are used, and middle one is the rotor, is the N and S pole motor. We switch each of pole alternately. You can see we give into the supply, the N pole can be attract. After that we switch to the another pole, rotor can be attract. After that we can switch the another pole, the rotor can be attracted. We can give to the fixed supply to the 3 poles, the motor can be jerked, the motor can be magnetically coupled. Hence, at that moment, motor cannot be run. So, we can use the alternately supply. We can give each pole alternately, sequentially to achieve the speed of the motor. We can frequently switching of a pole's supply, we can achieve the maximum speed. These BLDC motor are achieve the maximum 3000 RPM, maximum efficiency, maximum speed 3000 RPM. Also, we achieve the more than that by the using of the different controlling techniques and also the switching techniques. These motor are used in different vehicles like Hero, TVS, torque motor, Ather, Ola. You can see in a picture, the left hand side picture is a outer run motor, means the outer part of the rotor is rotating. You can see in a picture, the middle part is a stationary and outer part is a rotating. That's why we call it as a outer runner motor, means outer part is rotating. We also call it as a hub motor. It is called as a hub motor. And right hand side you can see the motor is connected to the upper side and it is given to the drive to the vehicle. It is directly not connected. By the using of the wheel, gear wheel, we can run the motor wheels also. This gear will help to the achieve the different speed. In Ather, Bajaj and Ola, this type of motor are used. But in Hero Electrics, TVS and Motor Torques is used the outer run motor. As per the requirement and as per their applications, use such type of motors also. The BLDC motor are mostly used in two-wheeler segment. In four-wheeler segment, most probably use the AC motors. We can discuss about the further, but in two-wheeler, we can use the brushless DC motor. So the next motor is a induction motor. This is a AC motor operate in a 3-phase AC supply. In a commercial or residential, we can use the single phase, but in industrial sector, we can use the 3-phase supply. This motor is the 3-phase supply motor. You can see in a picture, the most of the part is similar with the DC motor. One is the stator, second is the rotor, next one is the fan. Fan are used to the cooling of the motor. Fan cover are used for the protection of the dirt particle. Also bearing are used to reduce the friction losses. Basically, the induction motor has 2 types. First one is the squirrel cage motor and second is a phase wound rotor. These motors are most effective motor. Why? The construction are so much rigid and principle is so much simple. The power capacity of this motor is very high as compared to the DC motor. The size of the DC motor as compared to the induction motor is quite less. That's why most of the EV sector use the induction motor. The working principle of induction motor is very simple. The 3-phase supply is given to the stator side. You can see in a picture, the left hand side, it is given to the 3-phase supply, 3-phase alternating supply. And right side is the your construction, basic side view construction, side view structure of the motor. The middle part is a rotating and outer part is a stator stationary. The 3-phase supply is given to the motor. It can produce the rotating magnetic field. Why they can produce? Each phase is displaced 120 degree. That's why they can produce the rotating magnetic field, means RMF. This rotating magnetic field is rotate in between the rotor and stator area. In between the rotor and stator area. This rotating magnetic field is cut in a rotor conductor. Hence, according to the Faraday's law, the flux cut in a conductor, EMF induces of an conductor. Means the rotor conductor are energized and they can flow the current. These current produce own flux. So there are present two fluxes. First one is the stator flux, means RMF, and second is the rotor flux. To collaboration and interaction between the two fluxes, the force is interact and force is expressed and motor start to run. The basic working principle of this three-phase induction motor is electromagnetic induction motor. It is a phenomenon in which electromotive force induced across the electrical conductor when it is placed in a rotating magnetic field. Means the current carrying conductor is placed in a rotating magnetic field. It experiences a force and they can rotate. This motor is used in a different vehicle, but nowadays they cannot be used indirectly. Some physical and modifications are in a motor. They motor are used like a permanent magnet synchronous motors. But these induction motor are firstly used in Tesla models, Torque Zero, General Motors. These vehicles are used in an induction motor. You can see in a picture, this is a alignment of a four-wheeler to place an induction motor. You can see the battery pack, electrical motor, inverter circuit and gearbox. Why we are using inverter circuit? Because battery can store the DC and motor can run in a AC. So we can use the inverter to convert DC power to the AC, DC to AC. We can use the inverter to drive the motor. The efficiency of this motor is very high and also the power density of this motor is very high. That's why in a four-wheeler and most of the industries, we can use the DC motor. But also there are some disadvantages. The power factor is quietly less. That's why it is directly impact to the efficiency of the motor. That's why we can use some construction designing in an electrical vehicle induction motor. So use the further motor is the permanent magnet synchronous motor. What is meant by permanent magnet synchronous motor? These motor can run a synchronous speed. It is called as a synchronous motor. The synchronous is nothing but the speed of the RMF, rotating magnetic field. It is denoted as a NS 120 F upon P. This is a modification of the three-phase induction motor or the synchronous motor. It is similar like a induction motor and synchronous motor. This motor can operate only a three-phase AC supply. The permanent magnet are used to achieve the maximum efficiency of the motor. This motor is not a self-start motor. Previous study, three-phase induction motor is a self-start motor. DC motor is also the step-up motor, but permanent magnet synchronous motor is not a self-start motor. It is required some external power electronics devices, some external control circuit to run this motor. It is not required any external power supply also. So we can see in a picture there is a use of the stator by the placing of the copper bars. The copper are used for the minimize the resistance of the winding. There is the permanent magnet as a rotor magnet. The bearings are used to reduce the frictions of the vehicle or motor. In this figure shows that the cut sections of the different parts of the motor. The working principle is similar to the synchronous motor and induction motor. The three-phase supply is given to the stator. They can produce the rotating magnetic field in between the air gap of stator and rotor. This rotating magnetic field is rotate as their own speed. The speed is the 120 F upon P. Approximately, most probably in industries and commercial sector are used 1500 RPM. So the motor rotor is cannot capture at the initial type of speed. At that moment, the N pole and S pole is a permanent magnet is vibrated. It is a hunting. They cannot be capture the RMF speed at the initial moment. That's why we can use the controlling method. To at the initial, we can reduce the frequency at the starting of the vehicle. So rotor pole and stator poles are attract to each other and they can magnetically lock. After that, we can increase the frequency of the supply and achieve the desirable speed. We can increase the frequency, also increase the rotating magnetic field frequency, and they can couple with the rotor, so rotor speed can be increases. We can use the field oriented control method techniques, and this motor is a high power density motor, and also the torque is very high. That's why we can use the two controlling torque methods, sinusoidal categories method and trapezoidal categories method. These motor also use the controlling method are the VFD, variable frequency drive motor. The power density is high and torque is high. That's why these motor are used in most of the EV vehicles. You can see in a picture in Tata Nexon, Mahindra XUV, Nissan, Audi, BMW and Toyota and much more EV companies are used the permanent magnet synchronous motor because the power density is high, torque is high. They achieve the maximum speed at a minimum time. The most of the EV vehicles in a four-wheeler segment, there are used the permanent magnet synchronous motor. But there are some means the reluctance of this motor is quietly high. So minimize this reluctance, we can use the next motor is the synchronous reluctance motor. What is meant by reluctance? The reluctance is the opposition of the flow of flux. So the torque is directly proportional to the flux. We can achieve the maximum flux. Also, we can achieve the maximum torque. That's why we required minimum reluctance. We can achieve the minimum reluctance. We can achieve the maximum torque. That's why we can use the synchronous reluctance motor. Some modifications are in a rotor side. You can see it is similar to the three-phase induction motor. It is a construction is quite similar in a three-phase induction motor, also similar with the permanent magnet synchronous motor. But there are some modification in a rotor side. You can see in the right hand side, this is a rotor of inside of the motor. There is some cut sections. These cut sections are improve the reluctance and improve the maximum flux density. They can achieve the maximum torque of the vehicle. These motor are mainly in a two-part rotor and stator. Use the rotor as the permanent magnet and achieve the maximum torque. The air gap of this motor is very much less. By the using of this permanent magnet, we can achieve the maximum efficiency and maximum torque of the vehicle. The working principle is similar as the permanent magnet synchronous motor, means PMSM motor. The feedback in this motor the feedback system are used. Why? Because the controlling part of this motor is quietly difficult and quietly complex. That's why we use the feedback system. In a feedback system, we can use the maximum, we can use the Hall sensors and some other sensors to the sense the speed of the vehicle. The speed controlling of this vehicle is much more. The why the using of these cut sections? The some reluctance will be present in this motor. So we can use the field oriented control techniques to achieve the maximum speed of the vehicle. These motor are in a R&D section. So most of the vehicles are these types of motor are not used. So some design modifications are in a rotor side. We can use the switch reluctance motor. The switch you can see in a picture. The both motor, rotor and motor, both are the similar, but its difference in a rotor side. You can see in a picture the switch reluctance motor. This is a right hand side, and synchronous reluctance motor is the left hand side. You can see in a picture the switch reluctance motor. It is a rotor can use the projected type, means a silent pole type. The rotor is a projected type. That's why the stator and rotor magnetic flux reluctance will be less. And in a synchronous reluctance motor, we use the cylindrical type rotor. Which type of motor? Cylindrical type of motor. That's why the reluctance is comparatively high with respect to the switch reluctance motor. The switch reluctance motor is comparatively low reluctance and use a single phase operating. It uses a single phase, but in synchronous reluctance motor is use the 3-phase operating system. Nowadays, there's some modifications in a rotor side, in a stator side to achieve the this type of motor are used in a very high specific application. The Tata Motors are gradually designing R&D, research and development in this type of vehicles, this type of motor, switch reluctance motor, permanent magnetic synchronous motor, and switch reluctance motor. You can see the projection are the minimize the reluctance. The stator side also you can see the use the poles, but in a synchronous reluctance motor, the stator side has the distributed winding, means winding as not a concentrated, winding as the equally distributed over the stator. But in switch reluctance motor, the stator side, the concentrated winding are used, means each slot or each pulse has a some amount of the winding. But in synchronous reluctance motor, there is a distributed type winding are used. Now we can discuss about the working principle of the switch reluctance motor. You can see in a picture, we can use the 3-phase poles A, B, and C. They are splitted into 2 parts. See in picture A, A1, A2, B, B1, B2, C, C1, C2. They are replaced 180-degree approximately. The working principle is quietly similar as a BLDC motor, but they can operate a single phase supply and also the 3-phase supply. This motor is not needed any feedback system. That's why the controlling is easy. But in previous motor, you can see in this motor, switch synchronous reluctance motor, we can use the controlling system or feedback system. That's why the controlling part is some difficult or some complex. But in switch reluctance motor, it has a minimum reluctance and no feedback system. That's why the controlling is easy and less complex, but the power factor is less. That's why the motor efficiency is quietly less with respect to the synchronous reluctance motor and also the permanent magnet synchronous motor. This type of motor are used projected type pole. You can see this is a projected, this is a cylindrical, and this is the projected. Okay, the working principle, we can give to the supply to the poles. First of all, we can give to the supply to the A winding. So rotor is start to rotate, means the rotor is the permanent magnet. They can attract to the coil A, so they can rotate in clockwise direction. You can see in the picture at a 45 degree. Next, we can give to the supply to the B coil. So these pole, you can see this pole of a rotor is can attract to the pole B. So they can continuously rotate at a 75 degree. Now next, we can give to the supply to the pole C. Pole C. Also rotor can be rotated. You can see the picture rotor, they can be rotated. We can adjust these switches of the given to the supply to the winding or poles. We can achieve the different speed. We can given to the constant switches supply, we can achieve the constant speed. We can increase the switches or switching frequencies to the supply to the given to the coil, we can achieve the maximum speed. We can using the projected type rotor, so we can achieve the minimum reluctance. That's why we can achieve the maximum torque compared with the synchronous reluctance motor. Why? Because we can reduce the reluctance. So we can reduce the reluctance, we can achieve the maximum flux. Also we can achieve the maximum flux, we can achieve the maximum torque. That's why nowadays these motors are mostly used at a heavy load vehicle, transportation vehicles also. There are need only a single phase supply. So the designing of the controller is quietly less. By the using of the PMSA motor, we can use the VFD, variable frequency drive. These as the controller is a comparatively large in size as compared to the switch reluctance motor controller. That's nowadays the limited or limited MNCs companies are using this type of reluctance motor. The which are used the Land Rover and Tata Motors. These motors or these vehicles are used the switch reluctance motor. The Tata Motors is randomly using of the R&D in this switch reluctance motor because they are achieve the maximum torque at a minimum speed. The performance of this motor is very high in a gradient mode also, in 70 degree gradient and also in an inclination. They are achieve the maximum torque with respect to the speed also. They can also achieve the maximum speed. But the power factor is low of this motor. That's why PMSA motor is most preferable motor in a EV sector. You can see this is the comparison of the all these motor. We can discuss the DC motor, BLDC motor, AC induction motor, permanent magnet synchronous motor means PMSA motor, synchronous motor and SINAP motors, and SRM motor means switch reluctance motor. These motors are compared to each other by a using of the different characteristics like a power density, efficiency, controllability, reliability, technical maturity, and speed control. You can see in a first DC motor, the DC motor has low power density, low efficiency. Why? Because in DC motor we can use the brushes. The major part of a DC motor loss by the using of the brushes. There are happen in a friction, arc, heat. That's why the performance of the DC motor is gradually reduces. That's why the power density is very low, efficiency is very low, but controllability is very high because we using the only the supply side. We are given to two supplies, stator side and a rotor side. We can operate the both, stator side also and rotor side also. We can use the both as a increasing the speed and decreasing the speed. That's why the controllability is very high, reliability is medium, technical maturity is very high. That's why it is some modifications in DC motor to switch with the BLDC motor. The speed controlling is very low. So modification of DC motor is the BLDC motor, means brushless DC motor. The power density is high, efficiency also is high. To compare these two motors, DC motor and BLDC motor, the efficiency is very high of the BLDC motor. Why? They are not using any brushes. That's why the BLDC motor, the efficiency is very high. Controllability is also high, reliability is high, technical maturity is also high, and speed controlling is very much simple. Next is a induction motor. The power density is medium compared to this motor, PMSA motor, synchronous reluctance motor, switch reluctance motor. Compared to this motor, the power density is medium, efficiency is medium, controllability is very high, reliability is very high, technical maturity is very high, and speed controlling is very high. In DC motors, we can use the simple controlling methods like a speed controlling method. Star delta also use the controlling methods also. Why? Because the induction motor has a three-phase supply. They are connected in the star or delta. Also use the field-oriented controlling method. These are the advanced method. The field-oriented controlling method. By the using of the frequency controlling, we can achieve the different phase speed at a starting of 0 to a 5,000 RPM. 0 to 5,000 RPM, we can achieve the different speed. We can run also the 4 RPM, 100 RPM, 1000 RPM by the using of the field orientation control method. The next is the permanent magnetic synchronous motor. This is a PMSA motor. It is a similar with the induction motor and synchronous motor. The power density is high, efficiency is very high, controllability is high, reliability is also high, technical maturity is high, speed controlling is high. The efficiency is high. That's why the most of the EV sectors or EV companies are use the PMSA motor. You can see in a previous slides also use the Tata Motors. These companies, Tata Motors, Mahindra, Nissan, Audi, BMW and Toyota. This type of motor, this type of EVs vehicles are used the most of the PMSA motor, permanent magnetic synchronous motor. Next is the synchronous reluctance motor. The synchronous reluctance motor is the run at a synchronous speed. The power density is high, efficiency is also high, controllability is very high. Why? Because using the various controlling techniques, use the feedback system, different feedback system by using the Hall sensor. That's why controllability is very high, reliability is high, technical maturity is also very high, and speed control is also very high. nowadays we can use the switch reluctance motor. The switch reluctance motor is power density is low, efficiency is medium, controllability is medium, reliability is very high. Why? Because of using of the minimum reluctance, the reliability is very high, the technical maturity is very high, and speed controlling is very high. These are the comparison of the different motor with respect to the characteristics of a motor. So as per the our means customer requirement, as per the companies, as per the designer, they can decide the which type of motor are used. Compare with the all these motor, we can see the PMSM motor is contributely very high in a EV sector. Power density is high, efficiency is high, controllability is high, reliability is high. Most means all these characteristics, PMSM motor is performing well. That's why the most of the EV vehicles are used permanent magnet synchronous motor. So we can discuss about the different types of the motors, but what is the basic need? What is the selection of the vehicle? What is the criteria of the vehicle? This is the selection of the vehicle and criteria of the vehicle. The first one is the weight of motor. We can use high efficient, high density power, high torque motor, high speed motor. We can achieve everything, but the weight of this motor or overall construction of this motor or overall controlling part of this motor, the weight is been gradually increases. So performance of the vehicle or power capacity of the vehicle is increases. So it is a major part of the weight. So we can use minimum weight and maximum power motor. Next, the frontal area. Frontal area means a vehicle frontal area. The frontal area is large. It is required more resistance. It is give to the more resistance, drag resistance, air resistance. So it is required more power to the motor. So we can use the high power density motor. In highways and achieve the maximum speed, we can use a high speed motor, maximum speed required motor. And also in a inclination or gradient, we use the high torque motor, because in gradient we can achieve the load capacity, maximum load capacity and maximum speed at a maximum torque. We can use the maximum torque motor. Also the power has the maximum power, density will be high, and gradability is also high. Gradability means it is a gradient will be the they are the achieve the maximum torque at the gradient. These are the selections of the electrical vehicles. Okay. So any questions in this webinar? Different types of motor in electrical vehicles.
Good evening, sir.
Good evening.
Sir, myself Shilpa Agrawal. Hello.
Hello. Yes, ma'am.
Sir, can we have this video or PPT on our email ID?
Okay, I will discuss with my team and I will be arrange some this type of. You can
Yes,
share
sir.
with
The content was very nice and we liked it. And as we are teachers, faculties in the engineering college, so we need some things to be given to the students. It should be delivered to students. So that's why we need this PPT.
Okay, sure, ma'am. I will discuss with my team and I will share
Yes,
this.
sir.
Okay.
Yes, sir. The contents and this PPT just we want on our email ID, sir. It is just a request.
Okay, sir. No, okay, ma'am. No issue.
Fine,
Thank
sir.
you. Everyone, any questions regarding this topic or regarding with the EV sector or electrical vehicle? Please free to ask, and please ask any question regarding with the what is
Good evening, sir.
about the F1.
Good evening, sir.
Meaning yes. What about the controlling?
Good evening, sir.
Good evening. Yes.
Sir, this video can we provide my email ID?
Yes.
Lecture
Yes. Yes.
video.
Yes. Yes. Yes.
Okay, sir. Thank you.
So, okay. The someone is text the message.
Good evening.
Good evening, sir. Good evening. Yes.
Advantage of
Sir, voice is not clear. Please text. Please a message in message box. The some given to the one questions. What about the controlling circuitries are used in motor? Basically, in controlling EV vehicles, are most of the use of MOSFET or IGBTs, switchings. The electronics equipments are major role in these controlling techniques. The MOSFET is the best of high efficiency. We can use the active particles and also the passive particles. Also use the resistance controlling. These resistance are the use of produce the more heat. That's why we can use the electronics part most of the MOSFET and IGBTs. We can use the you can study about the both of in engineering background. You can study about the inverter circuit. Six switches are used in inverter circuit and converter circuit also. These switching are used in controlling of the vehicle. Most probably in DC supply, you can use the MOSFET or IGBT. The AC, we can use the IGBT also. In history, is used the thyristor. Nowadays, we can use the MOSFET. The broad, this is the controlling part, because most probably you can see in any controller, you can see number of ICs is connected in a series parallel combinations to minimize the switching frequencies and overloading also. Which battery are used in EV? So most probably lithium ion cells, lithium ion battery means use, but NMC are also used, nickel, cadmium, these type of batteries are also used in these EV sectors or EV vehicles. Sir, why cannot be used BLDC motor? So next is the why cannot use the BLDC motor in four-wheeler. So as per the applications, means the way company can decide it. The BLDC motor you can see in a slide also. You can see this slide. You can see the difference of BLDC motor and PMSC motor. Power density compare with these two motor, BLDC motor and permanent magnet motor. The power density is very high of PMSC motor. So power density means the power in per unit area. Means the BLDC motor has give, for example, the BLDC gives has a 100 watt and size will be considered as a size will be the as compared to PMSA motor, the size will be high. But in PMSA motor, the power density is high. That's why the size of PMSA motor is very less compared to the BLDC motor. In four-wheeler, we can achieve the maximum luxuries. You know that AC, these components are the maximum. That's why we require the maximum space in a four-wheeler. That's why we use the compact size of the motor. So we choose the high power density motor, which is the permanent magnet synchronous motor. So next is the how many types of electrical vehicles there and names. We can see the different vehicles, Land Rover, also two-wheeler in you can see electricals, Heroes, TVS, Torque Motor, Ather, Bajaj. Most of the automobile sector are switched to the EVs. Why? Because the government can give to the subsidies. That's why most of in two-wheeler segment also the local vendors are also introduced their own vehicles. You can see in different in cities, the local vendors are also produce their own vehicles because the concept is so simple and it is a very economical and eco-friendly. That's why. Anyone has another questions? What is the maximum range of EV vehicles? So this is also the depends upon the company. The Mahindra can achieve the 4, I know that, but it is approximately going to the 200 kilometer per hour speed maximum. As per the company, two-wheeler can, as per compare with the requirement of the companies made by the companies. Some companies are made a two-wheeler segment. They can achieve the maximum 80% speed, maximum 100% speed, 100 kilometer per hour. Ola, Ather, they can give the 120 maximum speed, 180 maximum speed. But in Hero, they can give to the maximum 80 speed, 40 speed. That depends upon it is on a company and designing of the vehicles. Anyone else has more questions? Please ask to free. So there is a question of Sharma sir. Why EVs are more expensive than the conventional contributed parts of the how to reduce this problem? Okay, the basic questions are the why EV vehicles are expensive. Yes, compared with the other vehicles, means IC engine vehicles. So the main part is a battery. The vehicle's main part is a battery, the charge, storage of charge. The battery is comparatively there are the 60 to 70% of total price. Means you can give 1 lakh vehicle, 1 lakh of the price of the vehicle two-wheeler. The 60,000 and 70,000 is only of the battery price. Only of the battery price. Why? Because the lithium iron has been the rare material in earth. You can also to find some lithium iron storage or lithium iron in Jammu Kashmir also. So it is a developing. We can also contribute some goes to the now introduce the sodium ion cells. The sodium means sodium, you know that sodium salt, sodium also. they can achieve the sodium cells battery, the price of the battery is gradually decreased. This 15,000 battery, it comes into the almost 10,000 because there is sodium ion. That's why the battery price is high. That's why the EV vehicles is price is high compared with the other conventional vehicles. How many types of EV car batteries charged? Battery cycles. This is also with the types of batteries. Basically, lithium iron cells are used, lithium nickel cadmium cells are used, lithium magnesium cells are used, lithium titanic cells are used. Each battery has different cycles, but lithium iron cells give the maximum cycles. Cycles means charging or discharging. Once one time charge and then discharge, it is called as one cycle. Okay, the lithium ion goes to the up to the 3,000 cycles also.
Thanks, sir, for hosting the webinar. Your expertise and insight were invaluable for our learners. I would like to take the opportunity to introduce our company, ISI India Product and Services, that we offer EV technology with small video. So kindly have a look on video.
As we are living in the fast-changing world of electric vehicles, ISI India is leading a tech organization, paving the way for innovation and devotionalizing the ecosystem. It is bridging the gap between industry and academia and bringing all the stakeholders to the same table. From 2013, our parent organization has been tirelessly working to create an ecosystem for skill development, research, innovation, and entrepreneurship in the electric vehicle industry. Through CSR skill development and partnership with GIZ, Tata Technologies, Bharat Crop Science, Kalika Industries, Chalna Jan Seva, Masiya, ICA Laboratories, etc. And with national and international e-mobility events such as Electric Solar Vehicle Championship, Formula Imperial, Indian Karting Race, E-Bike Design Challenge, we have provided a platform for over 3 lakh students from more than 750 colleges and universities to come up with the innovative projects. In addition to this, we are offering various skill development programs, faculty development programs, corporate trainings, and spectrum of courses with duration from 9 to 12 months with live and recorded interactive classes, with the added flexibility of paying after course completion. For our contribution towards building sustainable way forward in EV, we have got recognitions such as the National Youth Award from Ministry of Youth Affairs, Government of India, Titans of Technology Award, EDN Star Award from Earth Network USA, and the Social Entrepreneurship Award. And we have also joined hands with Automotive Skill Development Council, All India Council for Technical Education, National Skill Development Corporation, Ministry of New and Renewable Energy, and various automotive industries, which validate our global impact and commitment towards excellence. We are now a global partner for talent nurturing in the automotive industry. We are fostering the youths for the global EV market and have recently joined forces with partners in Malaysia, Indonesia, and South Africa. According to the economic survey, in India, the market for electric vehicle is expected to grow really fast, about 49% every year from 2022 to 2030. This means we could see 10 million electric vehicles sold every year, in which led to 50 million direct and indirect jobs by 2030. We are committed to sustainable mobility solutions, and our industry-aligned programs cater academia, industry, and government sectors. Our expertise in the industry has led us to design cutting-edge technological solutions for the growing electric vehicle industry. We promote project-based learning, hands-on training, skill development initiatives, vocational training, research, entrepreneurship, public-private partnerships, awareness and outreach programs. Our state-of-the-art facility, the Center of Excellence for Electric Vehicles, is dedicated to spreading the word about electric vehicles by facilitation of technological advanced solutions. EV Tech Lab. It's a high-tech lab designed for students studying engineering, ITI, and polytechnic, students getting job training. Think of it as a space where creativity meets actual hardware solutions. People here get to dive deep into the physical part that make electric vehicle work. This model is also helping our partners for community skilling of various job roles, such as electric vehicle technician, vehicle assembly operator, charging station operator and technician, and workforce for electric vehicle powertrain, battery and BMS maintenance, etc. Second model, that is our Center of Excellence for Electric Vehicle. It's a combination of labs and offering both hardware and software solutions, under which we have established end-to-end solutions for electric and hybrid vehicle design, powertrain, battery and BMS, EV charging, IoT for experimental learning, testing and prototyping. The solution we are providing is unique and help our learners for upskilling, research by getting experimental data and plotting graphs. Our goal is to impart industrial knowledge by establishing pioneering center of excellence. These centers, developed in collaboration with universities, industry partners, and government entities. Our COEs provide integration of EV curriculum in BTech, MTech, and other academia programs. Research and vocational and skilled courses align with the national education policy. Plus, our COEs also support the startup ecosystem by providing facilities for design, prototyping, and product testing. Our labs are making difference. We have established several labs across strategic locations with all kind of stakeholders like industry, Hero MotoCorp, with Government of Kerala in partnership with MG Motors at 2 locations, IIT Mandi, private universities like SNMU, Pelgotias University, Sharda University, an NGO with Govardhaniko Village by ISKCON Temple, and various top universities and institutes across India. Our commitment to excellence is unwavering, and by 2025, we aim to establish over 250 plus center of excellence worldwide. With India rapidly moving toward an electric-only future, ISA India is well positioned to develop a workforce prepared for the international arena. Join us on this electrifying journey towards a sustainable and innovative future.
Thanks for watching the video patiently. So don't miss out on this opportunity to discover the endless possibilities of EV. So any of you want to enroll in this course, kindly send us inquiry through our QR code displayed on your screen and take your first step towards a more sustainable and exciting future. Thank you.
Thank you so much, ma'am.
Thank you.
Thank you, ma'am.